Yes, my name is Jeff Bonkowski. I am the Western Area Manager for Hazmat Control Technologies. I'm a retired career firefighter. I do volunteer work as well as multiple training. So I've probably got about 37 years in the fire service, actively or doing trainings, etc. I had trained to the level of a hazmat specialist, and due to that training and starting consulting work after I retired, that consulting work and trying to find a solution for some of the high hazard fires that we're faced with in the fire service led me to look for a solution that could make extinguishing these fires a little safer and quicker, not only for firefighters, but for the public. And that led me to Hazmat Control Technologies when I learned about F500 and Encapsulator agent technology. And my presentation today, I'm hoping to talk about how it can and will be able to transform the fire service and some of the applications that we are faced with on a daily basis. And just as a real quick introduction, when I started doing this and I've gone to these departments, I often hear, oh, we have fire hydrants, we have water, water's free, we have all the water we want. We don't have any issues, we don't need to try to be able to find a solution to extinguish some of these difficult fires faster. But as we are now learning, there's many areas, not only in the United States, but around the world that are facing drought conditions. So if you're familiar with watching the news here a couple of weeks ago, we saw on the news where it took 30,000 gallons of water to extinguish one car fire, one Tesla car fire. So if we're facing these drought situations and we're trying to ration water, do we really have that much water that we can spare on some of these difficult fires, again, that we could be faced with within our communities? So it gets down to are we using our water effectively? Is it being used, when we sit there and say, oh, it's free, we have plenty of it. Are we using it effectively? Here's an example. We have an industrial fire and we're using, traditional foam and water, and we're dealing with a three-dimensional fire. Foam and water are not able to extinguish that type of a fire. And in the process, we lose $1 million piece of apparatus, as well as a company that's a taxpayer for our community, because we sat there and we're not looking at solutions and we're not looking at new technology. So I'm hoping that, I can get, get you to understand that, we are hopefully offering a way that we can transform the way we fight today's fires, making things, again, safer for firefighters and our community when it comes to dealing with these types of a fire. And first off, I'm going to be talking about encapsulator agent, and the question may arise, well, what is an encapsulator agent? And to understand an encapsulator agent, we need to understand that we're not dealing with bubbles. We're not dealing with foam, which would be a mechanical way to extinguish. We're dealing in the basic building block of an encapsulator agent, as you can see, is a spherical micelle. And I hope through the presentation, as I talk about, you have a better understanding of how these spherical micelles are capable of encapsulating carbon molecules, polar solvents, non-polar solvents, and not only in the liquid phase, but also in the vapor phase. So I'm trying to hopefully get across to you the difference in how we work versus traditional foams. So as you look at F500 encapsulator agent, we also have to understand, there's a big push to try to find a fluorine-free solution to be able to fight our fires today. And, well, when we sit there and we look at encapsulator agent, that we offer that 100% fluorine-free solution, as well as being non-corrosive and biodegradable. It's a multi-purpose CUL US NFPA classified AB fire suppression agent, and a combustible, flammable, vapor, liquid spill control agent. So when we start getting into some of our spills and some of the different situations that we may encounter as firefighters, we're able to handle those types of situations. The first thing that we need to understand
technology
is, what is it?
The next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic nonpolar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the nonpolar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet. Encapsulator technology.
Okay, so that's a real quick breakdown of how, I guess you can say, what an encapsulator agent is. Okay, not only are we putting that skin on the surface, we're chemically changing the makeup of a water droplet. It's not a bubble. Okay, it's not a bubble structure. It's not a fragile bubble that can pop, burst, or evaporate away before it has any effect. We're chemically changing the makeup of the water droplet, and still within each of those droplets, as you can see, there's millions and millions of these spherical micelles, and that's where the encapsulation takes place. And not only is it the encapsulation, let's start talking about that fire suppression mechanics. Let's understand all of the benefits and how we can help to transform water in being able to extinguish these difficult fires. And if we sit there and we start going back to our basic fire chemistry, we understand if we eliminate or we have an effect on any one of the three legs of the triangle, we can extinguish the fire. And we've now come to learn with the tetrahedron that we also have a lot of unburnt fuels and a lot of carcinogens and toxins within the thick black smoke that's being released when we have these fires. So we're going to talk about how an encapsulator agent has an effect in being able to deal with all of these situations. The first is that rapid and permanent heat reduction, being able to drop temperatures that are in excess of 1200 degrees down to 120 degrees, 127 degrees in a matter of seconds with burn back resistance. We're looking at being able to encapsulate fuels, how we're able to render these fuels non-flammable, how it reduces the soot, the smoke, the carcinogens, improves our visibility of the air quality. And what's killing people faster in today's fires, our structure fires. I mean, 30 years ago when things were natural fibers, you know, survivability in fires was much better. Today, we're using so many synthetics. The death rate in house fires is greatly increasing and constantly going up as we continue to add more and more synthetic materials in our building materials. And then we're going to talk a lot about that free radical coalescence and how we're able to have an effect in reducing many things. So the unique features, the rapid droplet, being able to transfer that heat and to understand how it works, that skin that we put on the surface of the water droplet. Okay, it helps to drive the heat interiors to the wall. And I'm not going to say into the water, but it's going to drive the heat interior to those spherical micelles. Those millions of spherical micelles are in each water droplet. Okay, they're rapidly going to absorb that heat that's on the surface of that water droplet and then slowly release it into the water that surrounds them. Through that process, there's no steam. Again, we're eliminating that possibility or that chance for not only steam burns to firefighters when they're sitting there, they're making an aggressive attack, but if we've got people that are in the structure. If we're doing search and rescue because the call came in that we've got people in the building, okay, what are we doing? We're making it safer for them. We're not creating superheated steam. When we sit there and talk about the encapsulation abilities, being able to render flammable materials, gas, diesel, and other things, non-ignitable, non-flammable, we can go into the NFPA section 18A 77, and in there we're in the process, it's called a spherical micelle stability test, and it tests the ability of a spherical micelle to be stable in the presence of high heat, so it doesn't break down. And once it's encapsulated the fuels, even in the presence of high heat, it's not going to release and it's not going to ignite once those fuels have been encapsulated. And we have a formula, and we're going to see some videos here in a minute, but you know, the thing that we need to understand though is and many people get confused when they start to think about using an encapsulator agent, that if you know they have this big 9,000 gallon gasoline tank and they put a little bit of encapsulator agent on it, that all 9,000 gallons of gasoline is ruined. And it's not the case. There's a formula. It's 1 part of encapsulator agent F500, 8 parts of fuel and 40 parts water. It's a 1-to-5 ratio. Plus we need some kinetic energy. You know, we need that agitation, the water hitting the surface to be able to cause that encapsulation to take place. When we sat there and we talked about the tetrahedron, we also have that, again, the thick black smoke, the carcinogens. We're going to see some videos here where we show how encapsulator agents are able to reduce those toxins, the soot, how we're able to absorb and improve the air quality and reduce our risk of cancer in the fire service. And a lot of this comes back from a study that was done by Clemson University using an inverted glass funnel test. And as their fuel source, they were using toluene. And what they were doing is they were looking at 3 things when they sat there and they set this test up. They were looking at light transmission through the smoke column. They were looking at the buildup of soot on the walls of the funnel, and then the toxicity of that soot. So when they sat there and they put a 3% mix of F500 solution into and sprayed into that smoke column, they were able to discover that invisibility was increased by 68%. That soot accumulation was reduced by 97%. The gentleman with cancer in the fire service, with all the issues and things that we have, almost 99% toxin reduction. That's tremendous safety factor that's being brought to the fire service. How about we sit there and we start looking at, you know, a snowy, icy day and you have a steep roof and you need to possibly ventilate so that you can see or maybe release some of the heat. Well, guess what? How about we sit there and we now use an encapsulator agent in our water stream, and then when we open the door, instead of trying to go through the structure and find the seat of the fire, we start spraying and we start hitting that smoke column. And we improve our visibility. We reduce the heat in the structure, and we're sitting there and we're reducing the toxins and the soot that we're being exposed to as firefighters. But not only are we doing it for the firefighters, but again, let's go back to that scenario I gave you with victims that may be in the structure that you're searching for. If you're not creating superheated steam when you go in and start doing your aggressive fire attack, and you're improving your visibility before the ventilation crew can get up on the roof, what do you think that's going to do for the victims that may be inside that structure and their survivability? It's a huge benefit that we're looking at when we sit there and we start looking. And along, as we read into the Clemson report, it goes into some of the reasons why that they are, I guess, concluding that we have that effect, because we interrupt the vapor phase combustion where those radical coalescence and soot particles are formed. So I mean, it's a huge benefit that we're bringing, again, not only to ourselves as firefighters, but our community and survivability for any victims that may be within a building. So now let's discuss that encapsulation. When we sit there, we start looking at the Class A fires, the soot. Some of the different Class A fires, your structure fires, your vehicle fires. Well, yes, there may be some fuel involved, maybe some Class B elements. We most of the time consider the interior, they consider them a Class A. Dumpster fires, again, you never know what you might encounter in a dumpster. It could be multiple classes. And then we start getting into recycling, scrap yards, tires, metals. And, you can sit there and almost on a weekly basis find some place here in the US where we've had a recycling center that's had some type of a fire. And then we start getting into some of the deep-seated fires, our silos and hay and straw. When we sit there, we start looking at these car fires. There's, again, we're many different, again, classes of fires that we're dealing with. And today, we all know that, our cars, our autos are changing. You're starting to get more lithium, more Class D metals, magnesium, steering columns, parts. We can see that thick black smoke that comes off. But one of the other things is, let's see how little water. He's using a 20-gallon per minute nozzle. He's going around very quickly, knocking down the main body of the fire. He shuts the nozzle off as he walks around, and he's cooling the metal as well as working to extinguish this fire. Look at how little water. Again, you start looking at these drought conditions. In many cases, you go out on these types of auto fires, you're looking at 500, 800, 1,000 gallons of water. Here we're using a little 20-gallon of water, 20-gallon per minute nozzle. Look at how little water runoff you're seeing around this vehicle as he's extinguishing this fire. I'll speed it up here just a little bit just to show you. But again, very little water, very little runoff around the surface. You don't see it running down through the parking lot. And when they get done, it's cool to the touch. They've taken those high temperatures and they've dropped them down to something that they can actually put their hands on. Excuse me. I'm going to ask the question. Here, yeah, it's probably some water that's on the ground, but let's make the assumption that that's a fuel. What's it? Diesel fuel, gasoline? What does your department do currently to make that scene safe so that your firefighters can perform that extrication without having to worry about a spark or something that might ignite that fuel source that's underneath them? When we sit there and we start to look at an encapsulator agent and its abilities, this is a real quick video that shows a gasoline spill on the ground. They're using a 3% mix of encapsulator agent F500. They encapsulate half of it and then they light the other half on fire. And they allow it to burn for a little bit so that you can see it's not going to transfer across to the side that's already been treated. These firefighters going to come back with his nozzle. He's going to sit there and he's now going to extinguish the entire fire. And as I said before, we're not dealing with bubbles. We're not dealing with the mechanical way to suppress the vapors and to extinguish this fire. We're using spherical micelles, which are encapsulating the fuel, rendering them non-flammable. And as this firefighter with the torch goes walking through the area that was just treated with the encapsulator agent, he's going to kind of sweep his foot across to show that there's no blanket to break that will then make that scene unsafe. So you can sit there and you can make those auto accident scenes safer, again, for yourselves as firefighters and for victims that may be in that automobile that you're trying to do the extrication for. When we sit there, and I'm going to kind of let you listen to this, I want you to listen to some of the discussion and the talk, because they're going to call out temperatures.
Let's open it up and check this out. It doesn't give me temperature.
Okay, I want you to listen, remember 1,200 at the base and 1,000 at the ceiling. Now, look how rapidly, just a short period of time, he sprays into that through the window.
400 at the base, 250 at the ceiling.
Okay, so we had a rapid temperature knockdown. They then did another burn test later in the evening. They did a night burn. And again, I want you to pay attention to the temperatures as they start reading off the thermal imaging again. And understand, earlier we talked about burn back.
Good thermal layering inside the window. What's your temperature?
932.
932.
Yep, 932.
You guys had about 1,000, so you want to go? You want to hit it, Ron?
Yeah, lower stuff doesn't look like it's burning. No. That's stuff that from this morning.
The lower stuff stopped burning. Listen to the temperatures.
That's probably just coming from the straw. Yeah. That lower stuff's not burning. About 230 at the bottom and 930 at the top. That's it. I got 975 and I was inside. 932 at the top and about 300 at the bottom.
Okay, so we had temperatures of 230 to 300 at the bottom.
470.
Now we have that mist. Wouldn't be standing there if it was steam.
113. Yep.
How hot was that? What's your temperature in the hallway, guys?
I'm gonna speed it up here just a little bit.
From about 930 degrees to about
So again, from 1,000 degrees to standing in it.
120 in about 20 seconds.
Wow.
Of that.
I'm sorry.
Went from about 930 degrees to about 120 in about 20 seconds.
That's impressive. That's impressive.
And that steam hit me. It was no hotter than a shower.
No, that's not steam then. That wasn't steam. That's not steam. That was the vapor we were talking about.
So there we go. We just heard from this test, we saw pretty much many things. We saw that rapid and permanent heat reduction. Many times firefighters start talking about the thermals and we can't interrupt the thermals and the steam that's going to come down and bank down on them. Okay, well, here we just saw in a couple of training videos, okay, we were able to have an effect. We were able to drop those temperatures down without creating that steam. No hotter than a shower. The burn back resistance, you saw in the morning, we had temperatures at the base at 1,200 degrees. And then in the night burn, okay, what was burned the morning of, okay, we are only getting temperatures of 230 to 300 degrees. I mean, the differences that it makes. When we sit there and we start looking and we start talking about, again, that interruption of the free radical, okay, that thick black smoke. I'm going to try to pause this video as he starts hitting and using this nozzle. Again, it's only a 20 gallon per minute nozzle, 1% of F500 encapsulator agent. But as you can see, where's the smoke? I still see some fire, but where'd the smoke go? That encapsulation, that interruption of that free radical coalescence, where we're sitting there and we're having the effect on the free radicals in there, being able to extinguish this fire without, I should say, by reducing the toxins as well. But as you can see, we have a lot of fire. We hit it quickly, 1%. We go through, again, that mist that's coming off there is not steam. We are able to quickly extinguish this fire using very little water. We're now going to do our overhaul, and then spray a little bit more to cool the steel belts. Once he gets done cooling those steel belts, you'll be able to take your glove off and be able to touch those. So when we sit there and start looking at, all the different applications, again, some of our other applications.
Hazard Control Technologies presents F500 Encapsulator.
When we sit there, we start looking at some of the wildland applications. These are from some of our Latin American partners where they've become a little bit more aggressive. They've become, again, looking for a solution to be able to deal with some of the fires that here in the US we keep fighting. We keep trying to find a way to deal with these, and here, our Hernan, I'm going to give him the credit for this. He's worked very, very hard and diligently to educate and train. And as you can see, they're sitting there and they're talking about, the encapsulator agent, the test, and they're talking about how they're using it within the community. In here, you're going to see how, as they learned about using it, it's making things cooler. They're extinguishing the fires quicker. They're gonna talk about the smell. It's because again we're encapsulating, we're getting rid of that burnt smell. We're encapsulating those odors. They're talking about how cool the area has become to the touch. One of the things when they sit there and they start talking about here is they're going to mention how in the past they might have had to have some of their workers make multiple entries into these fires to try to go through and do their overhaul and go through and find those hot spots. And by using encapsulator agent in the water in their backpacks, okay, instead of having to, they're doing much less work. They're not having to go back and forth as many times, long distances. What do you think that's going to do to your manpower? You're not going to be wearing your people out. You're not going to be stressing them. You're helping them be able to do their job more efficiently, more effectively. And they're being able to apply these in many different areas. And here Hernan has been working with these firefighters in Argentina and loading it up into tankers, being able to get out and hit those hot spots. So being able to cool it 3 to 5 times faster than plain water. So all of the benefits that we're seeing in wildland firefighting with the product, and not only are they mixing it into your tanker trucks, your shuttles, you're sitting there and you're looking at the backpacks, the fluorinate with the applications there. Let's speed this up here just a little bit. But there's a lot of benefit in being able to, again, when we sat there, we start talking about that burn back resistance. Okay, once we have that fire put out, and we've done our good extrication of it. It helpful. I'm going to back this up 1 second because I did miss one section that I wanted to. I want to apologize here. I sped it up just a little too much. We do have one where it's showing the application from an aircraft. It's not just something that they're using on the ground, but it's something that they're using for air drops, not only from the Bambi buckets with the helicopters, but they're also using it with your aircraft that are able to make their drops. Hey, Hernan, your airplane's missing.
No, the next slide.
This is the next one?
Yes.
Okay, I'm sorry. I thought that one had the airplane. Here's the airplane. Excuse me. But anyway, again, here we have, multiple applications. It doesn't just have to be put into our backpacks or our tanker trucks or our apparatus. Whatever we can get the encapsulator agent into, it's going to be very effective and work really, really well. We're going to start talking about Class B fires. And many times, again, when we talk about Class B, the first thing that comes to mind is, oh, hey, we have to get the foam out. And many times what we don't understand is, while foam in the past has always been the answer or the solution to these Class B fires, do we really know what the capabilities of that foam are? Because if we sit there and if we look at the Annex A11 of the foam standard, we're going to find that it doesn't work on three-dimensional fires. Okay, it will work on our two-dimensional gasoline or our ethanol and our diesel and our oils. It'll work on a fire like this, but again, we need to understand a fire like this has only 3 application techniques when we use foam. It's rain it down, bank it in, or roll it on. Those are the 3 approved methods. As you can see, this gentleman, this firefighter on the nozzle, it's the first time he's ever used F500 in his career. We're sitting there and you're going to watch just a rapid sweeping motion. And look how quickly in that rapid sweeping motion, he's able to knock down the main body of the fire. For a first attempt, never having used an encapsulator before, great job. Now, if you are using a foam, probably the most effective way to be able to extinguish or put that fire out would be to roll it down. Because of the heat, a rain down method would evaporate your bubbles very quickly. There's nothing on the backside of it to be able to do the bounce in. So the most effective to try to extinguish that fire would have been a roll-on method. And you would not have extinguished that fire as quickly. I will say, though, you need to understand the formulas yet. Okay, when we sit there and we start looking at our three-dimensional fires, what are they? I mean, again, we're dealing with all the things that we just covered. Okay, all the different hazards. And here with, again, this was done in Vietnam, where we don't have those unlimited water supplies. We don't have, you know, the availability of water constantly. And what they've done is they've created this training truck to be able to extinguish these fires. But again, we talked about that rapid decrease in temperature. Look at the safety equipment that we're using. I mean, again, not all countries have the ability to be able to provide, you know, the best and most current fire protection. But yet here we have these firefighters that are doing training. They're sitting there. They're going to use an encapsulator agent. And as they sit there and they start attacking this fire again, let's watch how quickly, excuse me, how quickly, even though they're dealing with a three-dimensional fire, how quickly they're able to have an effect on being able to extinguish it. You will not get this effect if you're using foam. And I can't really tell, but I think the guy on the nozzle, I don't even think he's got gloves. And here he is, he's gonna sit there and he's gonna open up his nozzle. And he's using a rotating nozzle that they've got over there. I believe they're both maybe about 60 GPM, so they're not flowing big water. They're not master streams, they're very small amounts. And they're quickly able to start hitting this, and they're doing 2 things. They're knocking down the fire. They're cooling the steel, which is a reignition source. Okay, so they're dropping that down below the auto ignition temperature, and they're working to encapsulate and extinguish this fire. It's a three-dimensional fire. If we sit there and we start looking at our methods that we currently use, we're using foam and we're using a dry powder. We're using a dual system to try to extinguish a three-dimensional fire currently. And now we can sit there, we can look at being able to use just one to be able to deal with these types of fires. And then we start getting into our Class D metals. Our cars are getting to a point where we're sitting there and we're trying to make them lighter and stronger. And not only is it with vehicles, but our tools. I mean, we start getting into some of our small engines and some of our garden equipment. We're seeing a lot more in the magnesium and some of our Class D metals there. Sporting equipment. I'm sure some of you got some titanium drive golf clubs. But when we sit there, we start looking at the hazards that it brings to the fire service. Okay, here we have fire, Class D metal plant. And again, we want to be able to try to have, put the fire out. I mean, this is a company that pays taxes within our community. We're trying to do our best to save it.
Okay, guys, I want you backing off. Go off the line, back off. Mike, let's pull out, go defensive. We're okay. Mike, we're gonna have. Are you working on the east side of the fire?
Okay, so as you can see, we have many areas, not just within the plant, but even now outside the plant. Some of the containers that have burning metals. And all of a sudden,
we got people down. We got people down.
So as you can hear on the radio call, we've got people down, firefighters injured. When we sit there and we start again looking at that encapsulator agent, we put that skin, that micelle skin, those spherical micelles inside the water droplet that rapidly absorb the heat and transfer it. So it's not truly water that's coming in, it's that skin that we've put on the surface of the water droplet that's helping to take the heat away and being able to rapidly cool and extinguish even these Class D metal fires. When you sit there and start looking at the way sometimes these Class D metal fires are handled, is you're looking at more of a fog pattern hitting the surface. You're sitting there and you're trying to do some cooling onto the metal, get that temperature down a little bit. And then as he sits there and as he starts to get that cool down, he's going to make a little bit more aggressive attack on it.
And are very dangerous to the fire.
But no place and no time while he was doing his attack did you see any mag explosions. You didn't see large sparks flying up in the air. And when he gets all done, he talked again, and I'm going to talk and say it again, that rapid cooling ability. He takes his glove off, and that once burning magnesium motor deck is now being able to be touched and held by hand because of that ability to rapidly cool. When we sit there and we look at our car fires, I mean, again, I bring up the fact that let's look, he's first spraying water to make sure he's got that milky white consistency in the water. Looks, well, something like 2% milk. Starts rapidly and aggressively attacking this fire. Changing the nozzle pattern is about the only thing that you see as a method. He's just trying to get around. You don't see a lot of water, again, on the ground, running away, running off. But when you sit there and he gets to the other side, you're going to see that magnesium steering column. Black smoke, even though you have fire, it's turned white. Now you see a little bit of that mag. And when you see that little flash, okay, he broke the crust off. When he sat there and before he hit it, there wasn't mag being really exposed and on fire. But as he broke that crust, he broke the surface and exposed it to air. He got that brief flash. Again, no explosion. But you see how he's able to now go after that magnesium and be able to cool and extinguish it without having that large mag fire or explosion like we saw in the previous video. Okay, how many fire chiefs have bought or had to buy new turnout gear because they hit a magnesium steering column and it exploded and burned holes in their turnout gear? or maybe even have an effect on a face mask with your SCBA. And then we sit there, we start looking at our lithium ion batteries. I mentioned earlier, for instance, that 30,000 gallons of water that was used earlier on a car fire. But it's not just cars. I mean, we have laptop batteries, the device you're listening to this webinar on, your computer, your cell phone, your tablet. We have these lithium ion batteries everywhere, and we keep hearing about the hazards and the difficulties that they bring. And we need to sit there, we need to look even in industry. Excuse me again. When we sit there and we start looking at these, replacing some of the vehicles that use fossil fuels, trying to be green, at a moment's notice, they can fail. We can have incidents where these batteries can just short out and catch on fire. The high-low driver did make it off. He is now going off to find himself a fire extinguisher, and you're going to see him appear over here on the right side of the screen. And he's going to be running back here. In fact, here he comes with his fire extinguisher, and he's going to start using that dry chem extinguisher on his lithium ion batteries. Some of his fellow workers are going to come along, and it looks like they're having a pretty good effect. It looks like that they may be able to extinguish this fire and get back to work here. But then all of a sudden, as we will soon see, powders do not cool and cannot stop thermal runaway. Sadly, the high-low kind of rolls off, and this entire warehouse is destroyed by a fire caused by a lithium-ion battery powered high-low. When we sit there, we start looking, testing that's been done. While here in the US, we always hear that there's no solution, there's no answer. HCT with our partner in, I should say Johnson Controls with our European partners, and Kiwa Labs have done extensive third-party testing. Again, we see on the far left, the dry powder with lithium-ion batteries. In the middle, we see foam, and look at the right, and we're going to see encapsulator agent F500. As they start with the powder, again, it appears that they may be having somewhat of effect. Looks like they might be able to do something, but again, there's no way that powder is going to be able to remove the heat. We can hopefully smother it, but until we get down below that auto ignition temperature, even if we smother it, if we start to unbury it, it's going to reignite. But as you can see, we have no effect with powder. When we look at using foams, they just seem to kind of agitate it, even make it worse. When they started using F500 encapsulator agent, and you look at the way he's using it, he's not using a constant spray. Again, very little water being able to be applied to encapsulate, to stop thermal runaway, but not only stop thermal runaway, but reduce the toxins being released when that battery is burning, encapsulating the electrolytes. The HF gas that's released when these batteries are burned is greatly reduced. The electrolytes that are flammable are encapsulated and no longer a flammable hazard. So when we sit there and start hearing reports of 30,000 gallons of water being used to extinguish a car fire, there's no need. And again, when we're looking at the results from the Johnson Control test that were published, okay, it shows that dry powders were poor, do not apply for lithium-ion fires. Your foam was moderate to poor, but again, not recommended. The F500 encapsulator agent in the extinguishers, and it can be recommended to apply on lithium-ion batteries. And in fact, it is recommended. When we sit there, we start looking at some of the different styles of lithium-ion batteries that we have on the market. This is like a polymer pouch style that has a little bit more of the electrolyte in it. When you sit there and you look at the encapsulator agent being applied to this, you can see how rapidly we're able to extinguish the battery. Even though that foil pouch is still protecting a lot of the heat source, is protecting the electrolyte, the encapsulator agent is able to still cool that metal pouch, that polymer pouch, encapsulate those flammable liquids in the electrolytes, and reduce the HF gases that are being released. Again, this is going to be another, I'm going to kind of speed through this one as I talk about it. Some additional testing that was done on some 18650 cells. And what I want to point out on this video is again, a couple of things. If you look on the top right, you're going to see a thermal imaging camera. But if you look down below on the bottom right, we have all of these temperature sensors that have been placed within these batteries. And I want you to watch as we sit there and we start going through. I'm going to speed this up here. We're going to get into a fire stage where we sit there, we start to see these fires go off. But I want, again, watch the temperatures as they continue to get higher and higher and higher before they activate the actual sprinkler system. We're looking at like your 330 degrees C. We're going to get some higher temperatures here briefly. Okay, we're starting to get 400 or 500 degrees C. So we've got some good heat going. You can see that in your thermal imaging camera up at the top. Very soon here now, you're going to see the encapsulator agent, F500 discharged. And I want you to pay attention to all of these sensors that are on the far right, because we talked about that rapid heat reduction, being able to even stop thermal runaway. That's such a hazard and a problem with our lithium-ion batteries. Okay, so here we go. Watch our temperatures drop as we sit there and we start getting the application of encapsulator agent. We've got temperatures 600-700 degrees. Now we're getting ready to have that release. We're dropping. Here we go. It's released, and within seconds, we've gone from 600 and 700 degrees down to 26, 25, 17. I mean, some of the sensors have gone offline because of how quickly or because of how high the temperatures were. But again, as they sit there, they start coming back on. We look at the ability of that F500 encapsulator agent to drop those temperatures from in excess of 500-600 degrees C down to 17 degrees C in a matter of just seconds. And when we sit there and we talk about some of the other hazards, that HF gas is being released when these batteries burn. When they sat there and they started doing, the testing on the hazards of that HF gas, and they were using water or without extinguishing, they were looking at anywhere from 227 parts per million to 2656 parts per million. But when they started using F500 solution, they were dropping those ppms of the HF gas down to 3745 or 1.25. And when we sit there, we start looking at our permissible limits for exposures. Again, important for people that may be in a building or in an area where these batteries are burning. When you're using an encapsulator agent, you're dropping and you're making those scenes safer. You're reducing your exposure to those types of hazards and those types of elements. When we sit there and start talking about our hazmat, while we deal with many things in hazmat, derailments, we start dealing with, our tanker incidents, underground, above ground, our tanker truck rollovers, our chemical spills, and some of the solutions that we may be called in to try to take care of, and our fuel spills. When we sit there and start looking at these train derailments, we bring up one here in Chile again. Hernan was very vital in this one. You're dealing with multiple incidents, multiple chemicals. They were dealing with the diesel from the locomotive, and they were dealing with sulfuric acid. Okay, and they brought along one agent. And so they sat there and they encapsulated the diesel fuel, making that safe. And then they sat there and they started using it on the sulfuric acid. And they were able to bring that sulfuric acid to a pH of 6. And in the process of bringing it to a pH of 6, there was no exothermic reaction. There was no cloud that was produced, excuse me, like you would see if you were trying to use just plain water. The difference it makes in being able to deal with these types of emergencies as well is huge in dealing with hazmat scenes. So they were able to encapsulate, they were able to reduce and eliminate that vapor cloud that you see in the very top. Okay, that was when they early on, humidity. They're trying to cover it with dirt. The dirt in the soil had moisture in it. And when they tried to use that, they were creating this cloud. And the reports are that, there was a prison downwind of where this was happening. This was, a truck accident. And they didn't want to have to move the prisoners because of COVID-19 and the problems that would cause. So the government and those were on scenes were familiar with F500 and its ability to encapsulate, to eliminate the hazards of that sulfuric acid without creating that cloud that would cause health problems or concerns downwind. And as you can see in the video, as they're sitting there and they're spraying the areas, if that had been water, you'd be seeing a huge cloud being developed. Here you're using an encapsulator agent. We're neutralizing the acid. We're bringing it to a pH of 6, which was pretty much normal. And we're not causing any serious effects downwind. Tanker rollover that occurred in Arizona, Globe, Arizona. We had 8,000 gallons of gasoline and diesel. It was rolled over and went down a embankment. And what did they do? They sat there and they brought the encapsulator agent in. As you can see, the gasoline, because they couldn't move that tanker truck because it was full. They needed to do something to lighten it up. So they decided that they were going to open up the dome caps and let the diesel and the gas spill out. And as it did, to reduce the vapors and to eliminate the hazards, they were sitting there and they were using an encapsulator agent at 3%. And they started flowing to keep those vapors down and to help encapsulate the gas and prevent a fire or explosion from occurring. After they got done, they were sitting there, they were able to then, as they brought the tanker truck up to the roadway, again, they continued to flow some encapsulator agent F500. Again, just to wash things down, make sure that there was no residual gas or anything residual that was on the outer shell of the tank truck, so that they could get the tank truck back up on the road and removed from that scene. So F500 encapsulator agent was used for some safety, as well as being able to help eliminate some issues. So through the presentation, I've kind of covered many of the different applications. We talked about the automobiles. We really didn't talk about transformers, but again, if we look at a transformer, we're talking about a class B fire. It's the oil in the transformer. Okay, we're not trying to attack a transformer that is still in the process of failing. This is a transformer that has failed, and it's now a Class B fire in a Class C environment. We talked briefly about those combustible dusts, so silos and the hazards. We did talk about that structure fire. Again, changing our method instead of waiting till we get to the fire to open up the nozzle. Now, when we open the door, when that thick black smoke starts rolling out, let's knock that smoke down. Let's reduce the heat, the temperatures. Okay, let's make so that we can have better visibility before that ventilation crew gets up there. Or you know what? We might not even need that ventilation crew. Again, you know, on a winter day, rainy day, metal roofs or roofs can become very slippery. It can be a way for firefighters to become injured. How many times have we seen firefighters or videos where firefighters fall through roofs? Okay, well, maybe we can eliminate the need for getting on roofs. We've talked about those Class D metals. We saw some videos with tires, and HCT and F500 has been used on 2 of the largest tire fires in the United States. Gila River, Arizona, and Watertown, Wisconsin. You know, those deep-seated fires that are difficult. And then our fuel spills. When we sit there and we talk about those fuel spills, I will add that we are on the EPA's National Contingency Plan as a surface washing agent to deal with those types of hazards and emergencies, and dealing with the spills that we might encounter. And with that, I'd like to open up and see if people have some questions. I hope I have you thinking about, you know, some of the applications and uses that could benefit your department and your community. And be more than happy now to open up the floor and take some questions. I want to appreciate everybody. I know I've got people from all around the world that are taking time out of the day. You know, some people it's morning and afternoon or evening. And again, I'd like to thank you for taking the time to be part of this presentation. And I hope it did bring some thoughts, some ideas, and hopefully maybe looking at some changes if you're with the department and how we move forward. And we start to look at the new technology. It's the 21st century. I mean, we went away from the tube type TVs to flat screens. Okay, well, it's now time to move away from foam and get into encapsulator agent. Let's get into the 21st century. Okay, let's learn how to fight fires safer, more effective. I mean, when I retired, I didn't want to be a couch potato. I had years and years, as I said, I trained to the level of a hazmat specialist. I got every training class and I did everything I could to learn what I could. And now, instead of just sitting at it, I want to make firefighting safer. I don't want to constantly see the death rate of firefighters because of cancer, because of falling through a roof, or because of doing other things. I want to see that end when we can sit there and we can start using 21st century technology and do things safer, more effective, not only for ourselves as firefighters, but our community and possibly victims that may be in a structure fire. And with that, again, I want to thank you all for attending. I hope you will take time out when we do a future presentation to share the same and learn more. And again, you know, feel free, as Ken mentioned, there's our address, hcta-world.com. Any questions that may come up, you know, tomorrow, next week, or whenever, hey, we're here to answer your questions. If you want training for your department to learn, we're here. We want to do the trainings. We want to help educate firefighters around the world. As you saw with the videos from Vietnam, you saw the videos from Argentina and from areas that, you know, all the different countries. I mean, we want to help. We want to change. We want to make things safe. And with that, I thank you, and have a great night, great afternoon, great morning, whichever it may be.